Hello friends, welcome to MAPHCH YouTube channel. Today in this video we are going to discuss about the problems on logic gates. In our last video we have discussed about the concept of logic gates, and I have promised you that I'm going to discuss some problems on the next video. So today is that video, and please don't skip it. We are going to solve each and every problem from basics to advanced level. You will find every problem from basic, and we will step by step we will go to the advanced level. Okay, in our last video we have missed about this XOR gate and this XNOR gate. Some people have commented about to tell that XOR gate and XNOR gate also. Today I am going to cover that XOR gate and XNOR gate also. Okay, let's start our video today. Okay, what is XOR gate? In our last video I have told you that this is XOR gate, but how it will function, what is the structure of, what is the digital structure of the XOR gate, how it will work. Just you imagine a staircase. This structure is popularly known as also staircase structure, staircase digital structure. In this digital structure you can find that, see, two wires are cross-linked, these two are switches, and there one is bulb. We need to connect to these two wires. Listen, if you think this wire as 1 and this as 0, this as 1 and this as 0, now how can we show that? Now the bulb is glowing? No, definitely not. Then how the bulb will glow? If I make a connection between this normal switch and to this one, will the bulb glows? See, the current comes like this and current flows through like this, and here the circuit is closed, but here the circuit is opened. If I have closed this circuit from here, then I also need to close this circuit from here also. Then only the current will flow through the bulb and the bulb will glow, isn't it? Now what I am saying is, we will connect to the first switch, which is marked as 1. Again we are talking about that binary system kind of thing only, nothing new in this. I am telling you that if we connect to this 1, then we also need to connect this switch to the 0, isn't it? Then only the bulb will glow, otherwise the bulb will not glow, because the switch is broken, the connection is broken. Okay, I will close this also. I have already closed this, so that now what we can write here, 1 and 0 inputs will give the bulb, will keep the bulb glowing, so that we are getting 1. So what we got here, 1 and here 0. I'm going to write here in this truth table. Okay, 1 and 0 is equal to 1. It is clear? Next, what I am telling is, if we broke this connection again, imagine it as completely opened circuit. Now this bulb is not glowing at all. Imagine. Now if I make a connection between the normal wire and this 0, and if I make a connection between this normal wire and that 1, now the circuit has been filled, circuit is closed, So that bulb will glow or not? Yes, definitely the bulb will glow. So what I am saying is, if it is 0 and 1, then the bulb will also glow. It is clear? Next, if I have only closed with 1, and I have closed with also 1. Here also I have closed with only 1. I have not connected this 0. I have opened this 0 circuit. Do you think the bulb will glow? If I connected with 0, I have connected with this 1, and I have connected with this also 1, then the current will flow? No, definitely not, because here the circuit will be opened. So bulb will not glow, so we will take it as 0. If it is 1 and 1, then it is 0. Okay, next, if we close this 0, if we close this 0 and we open this 1, let's imagine how the current will flow. The current will come like this, will go like this, and the current will come like this, and the circuit is open in this in this area. The wire is opened, the circuit is not full, the circuit is not closed, so the bulb will not glow, so it will be also 0. If we give the inputs 0 and 0, the output will also be 0. Okay, this is XOR gate, how the XOR gate will function. This is the example of staircase. This is also popularly known as staircase example. I have explained you that this is how the XOR gate works, and this is the Boolean equation of XOR gate. Remember this. This is the last one. This is the last XNOR gate which we have missed. And if you got XOR gate easily, then XNOR gate is very easy for you. Why? Because here the circuit looks very simple and it is very easy to understand. There is nothing great here. See, this is XNOR gate, known as XNOR gate. So how this circuit works? Again same, we will keep it as 1 0 1 0. If the bulb need to glow, then which switches should close and which switches should be opened? Now you only tell me which should be closed and which should be opened. Definitely, if we want to glow the bulb should glow means you have to connect this one and this one to the wires so that the circuit get closed and the current will pass through that. Means what we are giving inputs to this bulb, that is 1 and 1. If it is 1 and 1, the current will flow like this. See, the current is coming like this and the circuit is closed. The current is traveling like this and the circuit is closed at the 1, and the current is going in the direction of bulb and the bulb will glow. If the bulb glows, the output we want, which output we want, we have got it. So if inputs are 1 and 1, if the circuit is closed at 1 and 1, then the inputs are 1 and 1. If the bulb is glowed, then the output will also be 1. Just imagine like that. Okay, nothing great in this, it is very easy. Next, now imagine I have closed these switches, I have removed the connections, and I have gave the connection to this 0. I have gave the connection to this 0. Forgot about this 1 and 1. Now I am talking about these zeros. Now how this current will flow from the bulb? The current will come like this, it will come like this. The switch is closed here and the current will flow like this. In this direction the circuit is closed and the bulb will glow. If it is 0 and 0, the bulb will glow. If the inputs are 0 and 0, the output will also be 1, not at all 0. Next, I have closed this circuit. I have opened this circuit and I have closed this 1 and I have closed this 0. Now what do you think, the current will flow? No, definitely not. The bulb will not glow here. So if it is 1 and 0, then it will be 0. Same as vice versa. If it is 0 and 1, the bulb will not glow. This is the truth table. Remember this. This is the functioning of the XNOR gate, which is popularly known as XNOR gate. Not popularly, it is the name of that. And remember, this is the Boolean's equation of the XNOR gate. Okay, simple. Now you got it how the XOR gate and XNOR gate will work together. Okay, now we will talk about some problems. We will go through that simple problems to the next. We will discuss about this easy problems. Okay. Now, which gate is this? First, see the first question. Could you see? Yeah, it is perfect. See this first question. Which gate is this? Before starting this, I am requesting you people to pause the video which we are if we are discussing a problem, just pause your video and try to solve it on your own. Then only it will be useful for you. Otherwise it will be no use. If I am solving, you are seeing, then it will be no use for you. If take a pen and copy and parallelly try with me. If you are confident that you can do, if you are not at all confident also, pause the video there, copy down the question and try it on your own and comment below. Take this question number and for each question comment below what was the answer. Okay, don't just see this video and leave it. No, don't just do like that. Now we will start the question. Which gate is this? Which gate is this? Pause the video here and you try it on your own. Option 1, AND gate, OR gate, NOR gate and NOT gate. It is definitely a NOR gate. Remember this. This is the universal gate and we are having the other gate as universal gate. Which gate is that? This is OR gate. It is the universal gate. We are having one more gate that is also known as universal gate. Comment that in below. Comment below and see this gate. This is OR gate, isn't it? This is, we can see a half circle here so that we can decide it as O and remember that as OR gate. Sorry, NOR gate, because here there is a NOT gate also attached to this OR gate. Okay, this is known as universal gate. It's my mistake that I have explained you that it is OR gate. No, this is NOR gate. This is NOR gate. Okay, next, second question. Going to second question. Which gate is this? Could you identify which gate is this? Pause the video and make your answer. Yeah, let us see the question options. First of all, NOR gate, definitely not. First, in examination also, you try to eliminate the options. It is NOR gate. No, it can't be the answer. Next, NAND gate. It can't be the answer. it is not the answer. Next, NOT gate, no, definitely not. Now we have eliminated 3 options. Now we will see the 4th option. It is XNOR Gate. No, yes, definitely this is only the answer. Same as like this, you have to eliminate the options. Go for option eliminating method. Okay, if you are perfect at option eliminating method, you can do anything. Okay, now find the which gate is this. Identify this gate. Which gate is this? Is this OR gate? No. Is this XOR gate? No. Is this NOT gate? Yeah, it is. Is this AND gate? No, definitely not. It is not AND gate. Okay, next question. Which gates are known as universal gates? Which gates are known as universal gates? I have explained you just before the problem solving. Which gates are known as universal gates? See, first option, NOR gate and NOT gate. Definitely not here, because there is not gate here. This is not going to be the answer. And next, NOR gate and NAND gate. NOR gate and NAND gate. Yes, this is the answer. We will see the next options also, because we need to get a clarity. Okay, we need to feel the satisfaction feeling. We have to get that feeling. So option C, AND gate and NAND NAND gate. No, definitely not. Next, OR gate and NOR gate. No, definitely not. Next, we are having some more problems. These are the basic levels of the problems on logic gates. Now we will go to the PYQs. Now I am telling you the PYQs of this logic gates. Okay. Yeah, I think you can see the screen. Okay, perfect. First, take a pen and copy, and you people try to solve this question on your own. What you can see here, you can see a circuit here, and you can see 4 options. But how you can decide which method we need to follow here? Nothing great here. We need to take something truth table. We need to take here. Okay, means we are having A and B in this question. We are having a circuit here. We are having the output as Y, and they gave us the output Y should be 0, and we need to substitute each option in this circuit so that which of the options satisfy at the end the 0, the option is correct. Means what I am saying is, you need to substitute each and every option in this A and B. See, in option A we are having A equal to 1 and B equal to 1. We need to take A and 1 the input, B as 1 as input. Now wherever the circuit goes, if option A satisfies that it is A1 B1 gives at the end as 0, then option A will be right. If let us come to option B. If A equal to 0 and B equal to 1, we'll take it as inputs. If this inputs gives a output as 0, then option B will be right. Means you can able to understand what I am telling, that you need to solve each and every question. Now I will tell you how to solve it also. Just understand the question, how to approach the question. Instead of solving is secondary. If you know how to approach the question, you can go very close, because the logic gates are very easy to solve. Okay, we will take option A, as a equal to 1 and b equal to 1. Okay, I will take this as 1 and b as 1. Now see how signal a will go through the circuit. This is, we gave input for a as 1, right? See, this is 1 is going like this and 1 is stopped here. Next, 1 is also going like this. Observe this. The signal is jumping over this wire. The signal is jumping on the B wire. What I am saying is, this is called as jump, signal jump. This is going, forgot about this line. There is a wire here and a wire attached to the circuit is jumping over the B wire, and the signal is transmitted as 1, because the 1 will go like this and the 1 can come also like this. The 1 will come like this also. Okay, and here we got 1 and here also we got 1 up to here, and again we are having NOT gate. What is the function of NOT gate? Just imagine, if the NOT gate, if we give 1 to the NOT gate, the output will be 0 for the NOT gate. If we give input as 0 to NOT gate, the output will be 1 for the NOT gate. If we are getting 1 here, then definitely we will get 0 up to here. Okay, it is sorted. We have cleared up to this A wire. Now we will go to the B wire. What is B wire? It is also 1. Up to where the 1 is going? The 1 is going just like this. Okay, the 1 is going just like this. 1 is going like this and 1 will also come like this. Means it is 1, it is 1, it is 0, it is 1, it is 1, it is 1. So now imagine this AND gate here. Now see a AND gate here. When the signal will be transmitted from AND gate, very easy. If there is 1 and 1 inputs only, the AND gate will allow the signal to pass through it. This is 1 and 1. The signal is passed through the circuit as 1, because 1 and 1 will give the output as 1 for the AND gate. Here we got 1 and we are having 0 and 1 at the OR gate. The OR gate will give the output of 0 and 1 as 1, where we got 1 and 1 here at the NAND gate. This is NAND gate. If 1 and 1 is there at NAND gate, usually the AND gate will allow 1 and 1 as 1, but here a NOT gate here, so the 1 and 1 output is 1, so the output will transform into 0. So we got 0 here. So option A is the right answer. This is how the logic gates work. You need to solve each and every option, otherwise you have to take the truth table. Okay, I am not forcing you that this is a lengthy process. If you are perfect at one circuit diagram, if you are familiar with one circuit diagrams, and if you can approach to the question, the logic gates will automatically correct you. It will not take much time of you. Okay, we will go through the B option also and we will check what will be the output of that. We are having 0 and 1 here. Okay, we are taking 0 and 1. Here 0 is coming like this. Here we are having 0, and 0 will also go like this, and we are having 0 here. Next, okay, 1 is coming like this. We are having 1 here, and 1 is coming like this, and we are having 1 here. 0 and 1. If we are having 0 and 1 here, 0 and 1, the AND gate will not allow, so the output will also come as 0 here. Next we are having 1 and 0 here again. Sorry, we are having 1 here, right? We are having 1. The 1 will come here and 0. The 1 will transform into 0 and we will get 1 and 0. So we are getting 1 here. 1 0 will be 0 for AND gate, but there is NOT gate here, but so we will get 1 here. So definitely the option B is wrong. We need to check each and every option in the same method. So we can find that this option C and option D also wrong, because we have got this answer, we have got this option A as right. Once you also check with the C and D options which is correct. Okay, we will go to the next question, that is question number 6. Okay, now I think you can see the full question. No, wait. Yeah, I think you can see. Yeah, no problem, I will tell you. Now see, don't go through these options now, going and wasting the time for the each truth table may take your entire time in your examination. What I recommend is, for you only take a truth table. What I am telling is, you only take a truth table of your own. Take a truth table here, and what I recommend is, take 0 0 1 1 1 0 0 1. Why I am doing like this? Keeping each and every input into this circuit may eat your time. What I am telling you that, take 0 and 0, 0 and 0. If you know how to use the truth table, then the answers are very easy. See here, there is 0 and 0 here. Here we will get a 0. Here we will get a 0. Yeah, definitely. Wait a second. What I am doing? Yeah. Here we are saying that this is 0. The 0 will travel like this, and here is 0, and 0 will travel here, and this is 0, and 0 will be the 0 here. If AND gate inputs are 0 and 0, then we will get definitely a 0. Once you search that 0 and 0 are 0, yeah, it is 0. This option stays here. 0 and 0 are 0, yeah, this option stays here. Next, 0 and 0 are 0, yeah, this option stays here. Next, 0 and 0 are 0, yeah, this option also stays here. Okay, next, 0 and 0 we got 0. Next, we will check for 1 and 1. We will give 1 and 1 as an input. The 1 will go like this, and the 1 and 1 will go like this. 1 and 1. We are having 1 and 1. We will get 1 here and 1 here. 1 and 1 for the AND gate. The output will be 1. Now check here. 1 and 1 is 1. The option stays. 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 We cannot eliminate the options till yet. Now we will check for 1 and 0. Okay, we will check for 1 and 0. Now I am giving 1 and 0 here. The 1 will go like this. 1 stays here. 1 will also stay here. Remember, this is 1. This is 0 we got. 1 and 0, we will get a 0 here, and 1 and 0 should be 0. So we got 0. We got 0 here. So For what we have taken 1 and 0. Now search 1 and 0. We should get 0. Yeah, this stays here. 1 and 0, we got 1. The option B got eliminated. Next 1 and 0. Here it is 1. The option got eliminated. Here 1 and 0. 1 and 0. Here it is 0. Sorry, where it is? The option is only wrong. It is 1 1 0 1 1 1 0 0. The option is eliminated directly, because see here we are having 1 1 0 1 1 1 0 0. The option is directly eliminated because we are having 1 1 1 1 two times. Okay, you can check like this. Okay, we need to find the option, right? We have got the option also. The option A is correct. See here, we will check again for the safety. 0 and 1, we are having 0 and 1. We will take 0 and 1. 0 will go here. Yeah, 0 will go here. Next 0 stays here, 0 stays here, 1 comes here, 1 comes here. Next 0 and 1 is 1, and 0 and 1 should be 0. Okay, so what we have taken 0 and 1, 0 and 1 should be 0. Yeah, we got it. The option 1 is correct. This is the method that you need to approach to the question. This is how you have to approach. Next question. We will go to next question. Yeah, I think you can see the question here. It is a little bit bigger one. Please adjust for this time. Okay. We are solving this question. Okay, we are having a very simple circuit, nothing more. But how to make the truth table here? Does we need to take it on our own? We are taking the combinations of 0 0 0 1 1 0 and 1 1. We need to take here just like that? No, here we need not to take just like that, because they have gave us two graphs here. According to these graphs, we need to make our truth table. How to make it? See, it is very simple, that I will tell you. Make a truth table and see here, we are having a graph down here. Graph is not up. This graph is up, this graph is up, this graph is up, this is down, this is down. Wherever you see that graph is down, just mark it as 0, and wherever the graph is high, just mark it as 1. Now how to take? This is each interval. This is a specific interval the graph is representing about. We are taking 0 0, right? This is a specific interval. We are taking 0 1, right? This is a specific interval. We are taking 1 1, right? 1 0, right? This is a specific interval. Each and every line represent a specific interval, so that we need to take just like that. Then how to take? Take this as A. Mark it as A for your convenience, and mark it as B for your convenience. I am talking about this and I am talking about this. Okay. Yeah. In the first interval, where is the graph for the two cases? Here it is 0 and here it is 0. We will get 0 0, and we need to keep these two inputs here in A and B, where we will get a specific outcome output that we need to write it here, that we need to form a truth table, and we will check through each and every options which are there here. Okay, I will tell you how to do it. Just listen, don't do anything now, just stop doing something and just listen what I am telling. See, we are having 0 0, and just like that we will do for the other cases also. Here it is 0. Yeah, here it is 0, I am taking it as 0. Here we are having 1, the graph is touching the upper limit, so it is 1. Okay, next interval, here it is 1, I am taking it as 1, and next it is 1, I am taking it as 1. Here it is 0, I am taking it as 0. Here it is also a 0, I am taking it as 1, I am taking it as 1, 1 and 1. Here I am taking it as 1, and here I am taking it as 0. Enough. Don't go for all, just go for 4 or 5, that will be enough. Don't go for much. We are not interested to waste our time to solve everything in the examination. We are doing logic gates. The logic gate should give only +4, no -1. So how to solve this circuit? Now taking this all as the inputs, now you solve and tell me what will be the output of each input that we gave in the specific interval. You tell me these outputs. Let us assume this output as y. Okay, tell me, pause the video here and make your own truth table, make your own outputs and match that it is working out or not. We are having a NOR gate and OR gate here. Try it on your own and do it for yourself. Okay, done. I am going to do for you. See, 0 and 0, we are having 0 and 0. If the two inputs are 0, we are having 0 here, right? The signal will be splitted. See, the 0 is coming here, 1 0 will go here, 1 0 will come here. So the two inputs are 0 and 0, we will get 0 and 0. Okay, if the OR gate shows that 0 and 0 is 0, but here a NOT gate attached to OR gate, so it will transform the signal of 0 into 1. The 1 will come here and 1 stays here. Next, here 0 comes like this, 0 comes like this. 0 and 0 should be 0 and the 0 will stays here. The 1 and 0 at the NAND gate, it is NAND gate. Forgot about this NOT gate here, and we are having AND gate here. If we include this NOT gate here, so we will call it as NAND gate. Now you got it? Close this and think for some time. For AND gate, a input of 1 and 0 will what will be the output? It will be 0, but there is a NOT gate attached to that. If AND gate is giving that instruction, that input, that the signal should be 0, but no, AND gate will transform that and change it to 1. So we will get 1 here. Okay, now what you need to do in this options, see what I will tell you. Here you are here I think you can see these 4 options. Now 0 and 0 are 1, right? Now check. The first interval should be 1. If we are getting 1, the option sustains, otherwise we can eliminate that option. Here see, B is definitely not. We are having A, we are having C, we are having D. Yeah, we have got eliminated with one option, right? We are tension free. Now okay, now we will check for others also. You can see, yeah, you can. Now we are having 0 and 1. We will put 0 and 1, 0 and 1 as the inputs. Okay, I have taken 0, I have taken 1 here. Now 0 is coming as 2 inputs. 0 and 0 are 0, but there is NOT gate here. The NOT gate will transform the 0 signal into 1, and the 1 will come here, and we are having 1 here and 1. If the two inputs are 1, the OR gate allows the signal as the 1. If we are having 1 and 1, the AND gate will tell it as 1, but there is a NOT gate attached to here. So what NOT gate do is change the signal and keep it as 0. Now we got 0 here. Now come to the options and check where we are getting that 0 in these options. We are getting 0 here, the option A sustains, option B is however eliminated. We are getting 1 here, see in second interval we are getting 1 here, the option C is wrong. And here in option D also we are getting 1, the option D also eliminates. This is very simple. You need not to solve this whole entire thing. Just go through the option elimination method. For your help I will solve one more. Okay, we will take the input of 1 and 1. This time we will take 1 and 1. Here I am taking 1, here I am taking 1. The 1 is input, we are getting 1 and 1 as the input in the OR gate. Then the OR gate tells it is 1, but there is an AND gate attached to that, so 1 signal will be transformed into 0, then 0 travels up to here, 0 stays there. Okay, it is simple. Again we gave 1 input to the OR gate, 1 we got, 1 we got, 1 and 1 we got. The 1 comes here, 1 comes here. What was the two signals that should go as input? 0 and 1, right? 0 and 1 should be 0 at AND gate, but there is NOT gate attached to here, so 0 will be transformed into 1, we will get 1. Once check that option A is having 1 at third interval, yeah, the option is having 1 at third interval. It is very simple. This is how you need to deal with these graph questions in logic gates. If you follow these small steps in the logic gates, 4 marks are guaranteed. 4 marks are guaranteed. Okay, next we will go through the next question. Here in this question what we need to do, here we are having a circuit. Okay, now I got it. We need to take our own truth table. Here see, entire circuit will act as a specific single logic gate that we need to find. Here we are having AND gate, NOR gate, OR gate and NAND gate. Here we need to take our own truth table. Here we need to solve every 4 cases, each and every 4 cases, so that only we will get answer. Okay, first we will go for 1 and 1, 0 and 0, 0 and 1, 1 and 0. We need to solve this all. We need to go through this all 4 gates min steps. First we will take 1 and 1. We are having 1 and we are having 1. If the 1 is the input, how this 1 will come here? See, here we are having a signal jump here, and we will get 1 here also, 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 because the signal is jumping from here also. Just see these connections, how they are connected. If there is 1 and 1 here, here we will get 1, and here also we will get 1. If there is 1 and 1 as an input at the AND gate, then the output should be 1, but there is a NOT gate attached to here. The output will be changed and transformed into 0, and passing through that we are having another NOT gate attached, and the output will come as 1. So 1 and 1 is 1. Okay, we are getting 1 and 1 as 1. Now we need to solve for 0 and 0, 0 and 0, 0 0 0 0. We can take directly 0 0 0 0. Okay, 0 0 0 0, 0 0 is 0, definitely a 0, 0 0 definitely a 0, 0 0 is 0, but NOT gate will transform it into 1, and here Another NOT gate will transform it into again a 0. 0 0 is a 0. Next, here where the question get twisted, here we need to solve it carefully. Okay, let us solve. 0 and 1. We are having 0 and we are having 1. You can organize this writing when you are solving, but I am not able to organize here. You please take care of that, but otherwise you will be get confused. Okay, we are having 0 and 1, right? We have taken a 0 here, we will get a 0. Okay, the signal jumps come here and we will get a 0 here. Okay, next we are dealing with 1. The 1 will comes here, it is 0 and 1. We will go through this first. 0 and 1 is 1, we got 1 here. Okay, next we are having 0 here and the wait a second, yeah, 0 will come here and we are having a 0. 0 and 0 is 0, we are having a 0 here. 0 and 0 is 0, but it will transform into 1, again it is transformed into 0. Yeah, with this, whatever might be the case, 0 1 or 1 0, the output is same, is 0. Now which gate is this? Can you imagine? Can you find out which kind of truth table which truth table will show a specific gate? Which logic gate is having the same truth table? 0 0 0 and 1. There is only one gate which can show just a truth table, that is AND gate. That is AND gate. Remember, once recall, if we are having 0 0 1 0 0 1 and 1 1, for 0 0 it will be 0, for 1 0 it will be 0, for 0 1 it will be 0, and for 1 1 it will be 1. Exactly what we have done. This logic gate is representing that only. Okay, yeah, we have come to an end. Now a last model that I need to show you people, that is, yeah, see, they have gave us 4 options and each option containing 4 inputs. We need to show when the bulb glow here. Here see, this kind of questions are very rare, and these models are very important to solve also. When the bulb will glow, in a specific case, when the bulb will glow, see, I will take a simple circuit. I will take a battery and I will take a bulb and I will directly attach, I will directly close the circuit and make sure this is positive and this is negative. Means you know that positive terminal will have the high potential and negative terminal will have the low potential. It will have high potential and this have a low potential. Now the current will flow from high potential to low potential, or if the device is a little bit different, it might be vice versa. Whatever it might be, when the bulb will glow, at one end it should have high potential and at other end it should have low potential, right? This is very clear for us. In which case the bulb will glow at one side of the bulb we are having high potential, we should have high potential. At another side of the bulb we need to have the low potential. Okay, see, now what we need to do here is, if the high potential is marked as 1, then low potential should marked as 0, right? Means you have to check that if the bulb is getting 1 here, and next the bulb should get 0 here. That is the condition that these 4 options should satisfy. Whichever option is satisfying this specific condition, that option is right, that option is correct. Now how we can get that option, sir? Nothing great. We need to substitute each and every input that they have given here, 0 1 0 1. Okay, A is 0, 0 is going, it will be 0. Here we are having 0. Next, what is B? 1. What is C? 1. 1 and what is C? 1. 1 and 1. We are having 1 and 1. The 1 will be here. If it is 0 and 1, then definitely it will be a 1 here. It will be 1 here. And if we are having 1 here, yeah, then oh, sorry, it's my mistake. It is 0 because it is NOR gate. We are having 0 here and we are having 0 here. It is correct? Yeah, 0 0 is 0 and it will be 1. It is changed to NOT gate through NOT gate. Okay, next, what is 1? 1 1 is 1, but no, it is transformed and changed into 0. Yeah, this option satisfies. You have to substitute and see if the circuit is having 0 and 1 here, then it is correct. Otherwise, it is having 0 here and 1 here, then it is correct. Whatever it might be, the 0 and 1 should be attached, mean either sides of the bulb. In option A, the bulb will glow. The inputs that they have given to us, those are correct in option A only. And thank you for watching our video, and please like, share and subscribe to our channel. We will get such kind of things, such kind of lectures for every time. Please subscribe. If you like this lecture, please subscribe. Make sure that you have subscribed. Thank you.